should have some notes under that. Hopefully it's under that. And we have this, hopefully, linear equations slope-intercept form. Anybody else? Y equals mx plus b. Y equals 1/2 x plus 3. Tell me you have some notes that have something basically like that on it somewhere. So I know we did this before. Nobody's going. You do have something like that? All right. This, children, is slope-intercept form. Sorry, this is the generic way of it. This is an example of it. This is review because what we're doing today isn't this, but it's kind of related to this. How do I graph something in slope-intercept form? I think we went to the computer and did this and talked about this. This is where it crosses what? The y-axis, 1, 2, 3, has a slope of 1/2, which means it goes up 1 over 2. I mean, this should not be anything new to you. This is the graph of that, right? Sure, let's just go with that. Okay, that's not what we're talking about today. Today we're talking about linear equations, except they are in a different form. You're still going to get a straight line, but it's not written solve for y. It's what we call standard form. And it is written in the form of this. Ax plus by equals c. To which you'll say, okay, perfect. That just means instead of the letter A, B, and C, I'm going to put numbers in there. Let's say 2x plus 3y equals 6. Okay. I could rearrange all of this stuff and get it in this form, but I'm not going to. Okay. I could sit down and make a table, as I could have over here, put in x numbers and try to figure out what y thing is and graph it, but I'm not. When you run across an equation in standard form, you are going to write this down because you'll hear me say this 1,000 times. You are going to use x and y intercepts. Big hitter of the day. Use x and y intercepts. I'm going to let you write that because I need a new sheet of paper here. Got that one down, Cameron? Yeah? Big letter, underline 3 times like mine is. 2x plus 3y equals 6. Use x and y intercepts. Now, I will go slowly through this with the hopes that eventually you can do it quickly. But if I do it quickly right off the bat, you'll go, huh, and nobody will get it. Okay? It can be done much faster than I'm going to do, but I'm going to do it in slow motion. What you are looking for, this whole thing right here means you are looking for where the line, when you graph it, crosses both the x and y axis. In other words, this. I am looking, when I have my graph, for the place where this line is going to cross this axis and the place where it's going to cross this axis, because once I get those 2 points, I can draw my line. Now, obviously you're saying, well, how do I do that? Well, let me tell you how you do that. 2 steps. To find the x-intercept, you put 0 in for y. I'll let you write that down. Don't look at me blankly yet. Okay, check this out. Here it is in relatively slow motion. I want to find a place where it crosses the x-axis. To do that, I just put 0 in for y. Let me ask you a question. What is 3 times 0?
0.
When you put 0 in for y, that whole y term goes away. It is gone because it's nothing, because 0 times anything is nothing. I am left with 2x equals 6, and here's where you kind of have to do a little bit in your head, which hopefully you can do. 2x equals 6. 2 times what number is 6?
3.
3. That is the x-intercept. It crosses the x-axis at 3. Because when I put 0 in for y, I got 3 for x. If you want to see it outwritten as a point, here is your point. I put 0 in for y, and I got 3 for x. So the point 30 is right there. Guess what you'll do to find out where it crosses the y-axis? To find the y-intercept, put 0 in for x. Again, I'll show you that. Everybody's what's up here blankly at. If I put 0 in for x, what happens to the x term? It goes away. And I'm just left with 3y equals 6. If 3y equals 6, what does y have to equal? 3 times what number is 6? 2. So here, where the y is 2 on the y-axis, I have the y-intercept. If you want to see the point, I put 0 in for x, and I got 2 for y. Once you have 2 points, that's all you need to draw your line. This is that line. This is the graph of this line. 2x plus 3y equals 6. And that was super slow, but I'll show you how fast you can do this in a second as soon as everybody kind of 3x plus 4y equals 24. I'm going to do it like supercharged here. Just need to do this, okay? Put 0 in for y to find where it crosses the x-axis. That means this goes away, because 4 times 0 is nothing. If 3x equals 24, what does x equal?
8.
That's where it crosses the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. I need to find the y-intercept, so I put 0 in for x. Well, x goes away, so 4y equals 24. What does y equal? 6. So 1, 2, 3, 4, 5, 6. Bam, there's my line. Graphed. Just that easy. But please know that only works when it's in standard form. Don't try to do that if you're back in slope-intercept form. Slope-intercept form, you have the y, you have the slope. That's different than this form. Standard form, both the x and the y are on one side of the equation, numbers on the other. Slope-intercept form, the y is all by itself. It's solved for y. Another one. How about this one? Do you want to do the hard one first now? Well, yeah, let's do this one here. 3x minus 2y equals 6. No, equals 12. Now, some things you have to be careful of. So far, ladies and gentlemen, boys and girls, and kids of all ages, we have not done one where there's been a minus sign. That does change things, and this is how. It doesn't change things for the x, because if I put 0 in for y, Bellanuzo, if 3x equals 12, what does x equal? 4. So I know it crosses the x-axis at 4. Change colors. Here's where you have to be careful. If I put 0 in for x, This is not a plus 2y that equals 12, it's a negative 2y that equals 12. If I take 12 and divide it by negative 2, y equals negative 6. So negative 1, 2, 3, 4, 5, 6. There's negative 6, and that's the graph of that line. So you have to be careful when you get that there. Yeah, they don't give me anything there. Let's do one more. Negative x plus 3y equals 6. Negative x plus 3y equals 6. What is my x-intercept going to be? Somebody out there. Brooke Kala. My x-intercept is going to be, put 0 in for y, negative 6. She's correct. This goes away. Y negative because of this negative sign out there. Okay, you're dividing by a negative 1. So x is negative 6. 1, 2, 3, 4, 5, 6. What is my y-intercept? Alex? 2. Bam, bam. And that's the graph of that line. Standard form is relatively easy to graph, and there are a couple other hiccups, but we're not going to go over that.
Changing.
Well, not yet, because we have one more thing to do. One of the examples in the book gives you this. Well, take a look at page 552. Actually, no. Take a look at page 553, so that way you don't have the answers, because some of you like to cheat. Look at example E. Are you with me on example E? Example E says, Tanisha is thinking of two numbers. The sum of the numbers is 5. The sum, she's thinking of one number plus another number gives her 5, correct? And Tanisha says, when the smaller one is subtracted from the greater one, the result is 7. X minus y is 7. Graph this system and find the answer. What would be the answer to that? What two numbers, when you add together, is 5, but when you subtract them, you get 7? Good. I'm glad for the blank stares, because then you can actually say how this might actually be fruitful to the rest of you. I'm going to move this up here if I can. Okay. How does that even apply to what we did today? Well, we're going to do this, and here's why you need to do things accurately. I'm going to graph both of those lines. X plus y equals 5. Where's my x-intercept is, Ryan? 5. 1, 2, 3, 4, 5. My y-intercept for the first equation is? Somebody? 5. 1, 2, 3, 4, 5. So my first, all this line, boys and girls, this line, boys and girls, represents all the possible answers you could have when you add two numbers together to give you 5. For example, look, this is 1, 4. 1 plus 4 is 5. This is 4 plus 1. 4 plus 1 is 5. This line is every possible combination of two numbers that'll give you 5. You can even do fractions if you want, 4 and a half, whatever. Now we need to graph the second one. Whole different line. What's the x-intercept for the second one? 7. 5, 6, 7. What's the y-intercept for the second one? No, it isn't 7. It is negative 7. You have to be careful with those negatives. So here, 1, 2, 3, 4, 5, 6, 7. Put my dot there. I graph that line right there as best I can. This second line is all the possible answers when you take two numbers and subtract them to get 7. For example, here is 8, 8, 1. 8 minus 1 is 7. Here is 6. Oh, look, 6 minus 1 is 7. Oh, that's what it is. The place where they cross is the one and only place where both of these equations are both true. And what point is that? It's 6, negative 1. X is 6, y is negative 1. 6 plus negative 1 is 5. 6 minus a negative 1 is 7. Two different equations where they cross is the one answer that meets both of them. Isn't that amazing?
It is amazing.
It's
Life changing.
What's that? That is, no, don't go there. I'm sure we can probably play this game here. Hold on a second. Where's my stop button? Stop.